how to set them up and how to use your calculator to solve some of these, okay? So on 1-2, I think there's only 3 pages on this, just a very short section. And what we're going to look at is being able to write expressions based on some situation, okay? So this first problem says that you have the sum of two numbers is 50. Okay, that right there is a mathematical equation in words. So what I'm going to do on this is, let's just kind of start this off like this. Let's just say the first number, give it a variable, let's just call that x, okay? The second number does not have to be the same, so we're going to say the second number is equal to y, okay, like that. Okay, what would be the equation for the sum of two numbers is 50 then? X plus y equals 50, good. So let's write that down. That's an equation like that, okay? So we got that, x plus y is 50. Then what the problem says is it says express the product of the numbers as a function of one of the numbers, okay? So if the two numbers are x and y, well, what does product mean? That means multiply, right? So that means the product would be x times y. But we don't want that because what you're trying to learn how to do, when you get to calculus, you have to write this with one variable. Okay, so what I'm going to do on this then is this is not the answer. What you need to do is take this equation right here and decide which variable you want to solve it for. And it doesn't really matter. What I'm going to do is just solve this for y. So let's write this then as y equals 50 minus x like that. Okay, and remember our goal is to have our answer with just one variable in it. So what we're going to do is this is y, so that's going to plug in there, and then we would have our function. Okay, and we're not going to do anything with the problem, just kind of set this up. So what we would have is p is equal to x times 50 minus x like that. Okay, and that represents the product of two numbers. All right. Now let me show you, this is one thing that you can do to make sense of this. Let's just say that x is 10. So what would y be in your head? 40, right? Because they add up to 50, right? Well, let's see if this does what it's supposed to do. X is 10. That would be 50 minus 10. So wouldn't that just give you the product of 10 and 40? Okay, that's what that formula is doing then. So what you're going to do, and mostly in this section, you're going to set stuff up. You're not going to do anything with it. You're just going to set it up. Yes, you have something?
The product of 10 and 40?
Yes. Because see, what we're doing is we're trying to find the product of two numbers. What I'm trying to show you there is this expression right here is giving you the product of those two numbers. X is 1. The other one is found by subtracting from 50 because they add up to 50. So you're getting those two things in the same thing. Okay, and you see the thing is you want the answer on this problem to only have one variable. Does that make sense? Shake your head, tell me. Okay, this is stuff what we're trying to do is get people kind of ready for calculus and thinking about how you can put together an equation that would still express this with one unknown. Okay, that's the idea. Okay, so again, I've got two equations. That's the easy part. I know you understand that. The sum of two numbers is 50. The product is just x times y. What I essentially did is took this equation and plugged it in. That way I've got one unknown. That's the idea. Okay, and you'll see me do this throughout these problems. Okay, next problem says you have 600 feet of fencing to enclose a rectangular area. So a good way to do this is draw a rectangle. Okay, and let's label stuff and kind of figure out what our variables are going to be. So this time, well, I'm just going to keep doing x and y on this. I'm going to call that x, and I'm going to call that y. So if you have a rectangle, that's how your dimensions would go like that. Okay, so that would be our dimensions. Now, give me an equation. If you have 600 total feet of fence, what would be an equation based on my diagram? 2x plus 2y equals 600, right? Okay, because you're just that the total fence is like finding a perimeter. So you'd have x and x, y and y. So if you put that together, your first equation would be 2x plus 2y is equal to 600. Everybody with me there? That's what that statement says. Okay, now the next statement says this: express the area of the field as a function of one of its dimensions. What that means is you're going to find the area, but your answer is going to have one variable in it. Okay, so let's do this. Look at my diagram. Tell me how I find the area of that rectangle. I do x times y. I do base times height, right? So that's going to be x times y. So we want to write that down as x times y, but that's not the answer. Why is this not the answer? It's got two variables and we want one, right? So that means what you need to do is take this equation, solve for a variable, and plug it in. Now it's up to you which one you do. I'm just going to solve this one for y again. So we're going to get y by itself. So you could subtract or move the 2x the other side. So you'd have 2y equals 600, and then minus 2x like that. Okay, then I'll just divide both sides by 2. Okay, and when you do that, you're going to get y equals 300 minus x like that. All right, what am I going to do with that 300 minus x? That's y, so that plugs in there, right? So replace the y with that, then your answer will have one variable in it. That's the idea, okay? So the final answer we just say is a equals x. Okay, just take that, plug it in for y, and then you'll have 300 minus x like that. So that's actually a formula for the area of that rectangle. All right, is that clear? Okay, does that make the first one clearer? Okay, same idea. They're both basically the same idea. Now, a lot of what you're going to do in this section is just building equations. I'm going to do about 3 of these examples where we go ahead and use our calculator to do another part of this. You aren't going to do too much of that in your homework, just a little bit. Okay, this next one here is kind of a classic Calculus 1 problem. We're going to do this with the benefit of our calculator. So what this says is you have a rectangular piece of cardboard, and the dimensions of that are 30 by 15. So let's start this by just kind of somewhere, just draw yourself a rectangle. And let's label this. This side is going to be, we'll say that's 30 inches, and we'll say that one's 15 inches like that. Now what we're doing is we're making a box with an open top on it. So what you would do to make a box is you would just cut out squares all the way around the rectangle like this. Okay, and then once you cut those out, then you would fold over these lines like here. So the first thing is, if you've never done this before, you want to make sure you understand what's going on. So imagine you take a pair of scissors, you cut that square out, that square, that square, and that square, and fold everything up, you would have a box. Can you imagine that? Okay, that's what you have to understand is what we're doing, is we're making a box out of that. So the key thing out of this is you got to get your variables in here right. Okay, so what I'm going to have you do is let's just label that x. All the way around, we're just cutting out squares, and x is going to be our dimension that we're going to do. Okay, we're going to find out kind of what value of x will actually make that box the biggest possible, the biggest volume. All right, so watch carefully. Let's look at this. Let's think about what this side right here is. After we take our scissors and cut that out, let's think about algebraically what this would be. It starts 30, right? Then I chop those off, so what's left? 30 minus 2x, right? It starts 30 minus an x and minus another x, so that right there is 30 minus 2x, right? Okay, so that's what that dimension is, and that's important that you have that kind of put together like that. So that's 30 minus 2x. Okay, so that's a dimension right there. Okay, we're going to do the same thing over here. I'll just kind of highlight this in a different color here. Okay, same exact idea. So we want to think about what that would be. Okay, right here. Same idea. This starts 15, right? You chop off x and x, so what's left? 15 minus 2x, right? Okay, so it starts 15, take away 2 x's, then you're going to have that as 15 minus 2x. Okay, so those are the dimensions that we would have. So your box would kind of look like this. You don't have to draw this box, but this is kind of what's going on, is if I draw the box kind of like this, you're going to have this dimension's 30 minus 2x, that one's 15 minus 2x, and how tall it is going to be x. That's what's going to happen on the problem. Does that make sense? First of all right? Now, what we're going to do is the thing on this is it says express the volume of that box. How do you find a volume of a box? There's 3 things, 3 dimensions. You do what? Length times width times height. Okay? So that means the volume, I'm going to go ahead and write that as length times width times height. You don't have to, you just need to know that. So the length would be one of these dimensions. It doesn't matter what's what. We just need to do these dimensions and multiply them together, okay? And it doesn't matter what order. I'm just going to write it as x times 30 minus 2x times 15 minus 2x like that, okay? And that's the idea. Now we're actually going to do something with this in a minute with our calculator, because I do want to take these a little bit further than the book does. So the next thing is, what are the feasible values of x, okay? Now listen carefully on this, see if this makes sense to you. Okay, if this thing started, if that thing's 30, at the beginning, that's 30, what would be the biggest square you could possibly cut out that would make this problem even make any sense at all anyway?
25.
What'd you say?
25.
Not 25.
15.
15, okay? What would happen if you did 15 by 15? You would just have a little line, wouldn't you? Okay, so you wouldn't have any volume at all. You would just basically have, you fold your paper up and you wouldn't have a box, okay? How about this way? If that's 15, what's the biggest thing you can chop off there? 7.5, okay? So that's the idea. Really in this problem, once you get past 7.5, it doesn't make any sense anymore, okay? So really what I'm saying by the feasible region is this, okay? Basically, the smallest x, the minimum x would be 0. Of course, if you didn't chop off anything, then you would have no box, but you could chop off 0.001 and still get a little tiny box. And then the maximum would be not 15, but it would be 7.5, okay, like that. So that's kind of what your feasible regions are. So I'm going to just have you write this as an inequality, as in an interval notation, we'll say 0 and 7.5. And I'm doing parentheses around that because neither 0 or 7.5 makes sense, but everything in between does. Does that make any sense? Okay. So you wouldn't have a box if you chopped off 7.5. You just have a flat piece of paper with 0 volume. Okay. All right. Now get your calculator out. I want to show you something that I want you to be able to do on a problem like this. And we're going to do this totally with the calculator. Now the question is we're going to do a graph on this, and then what we're going to do is we're going to find the values of x that make the volume a maximum, okay? Now you'll learn how to do this problem without a calculator in calculus. So what I want you to put in y1, I want you to put in this thing right here, okay? You put in x, and then parentheses, don't even multiply it out, just put it in the way it is, 30 minus 2x. That gives you the base, close parentheses. Then you're going to do 15 minus 2x like that. Okay, so we're going to graph that. Now, one of the things you got to do when you graph something like this is you got to figure out what kind of window that you're going to use that's going to make sense out of this. So one of the things that I would suggest on here, when you do your window, first of all, you want to hit your window button, and we want to go 0 to, and let's go to 8. The reason I'm going to 8 is because we said 0 to 7.5 is where it's sensible. So I'm just going to go out one more to 8 like that. Now, the y value is going to be the volume. The volume is going to be really big. So what I would do to figure out my window is I would look at this table that's under graph. So if you go second, graph, and look at your table, let me show you what this means. And this is an important thing to look at as I go through this. What this is saying, these numbers right here, this is what this is saying to me. Okay, if you chop off, if x is 1, you would have a 1 by 1 square, you would have a volume of 364. Now look what happens to the volume. It gets bigger for a while, then what happens? Then it starts going down. Our job is to find what is the optimum value of x to use to make this box as big as possible volume-wise. So if I was doing a window on this, you need to be up to 700, right? That looks like that's probably about the biggest volume is somewhere in there. So what I'm going to do for that reason is on the window, and we'll go back to the window button, let's do the y's this way. Let's do like this. Let's do 0 for y minimum, and let's go to 700. And then let's scale that by 100 like that. Okay. All right, now we're ready to graph, and I'll slide this over the side if you need to still get that window put in like that. Now you type graph, and what's going to happen on this is that's kind of what the table is showing. The volume goes up, hits a high point, then comes down. Now here's the significance of that, okay? If x is 0, you don't have a box, right? If x is 7.5, you don't have a box, you have 0 volume. All right, everybody with me there? Okay. Now what our job is to figure out what this maximum is right here. Some of you have done this in high school and stuff. Some of you haven't. If you haven't, you should write down these keystrokes. We're going to find what that maximum is. So the way you do this, and I'll write down the keystrokes, write them down if you need to. You do second, and then you do the trace button. I like that. So you go second trace, and then you're going to go to number 4, which is going to find a maximum. You don't estimate. You let the calculator get the exact answer for you like that. Okay, so you want to go there. When you're on 4, just press enter. And then what it's going to do is it's going to ask you for a left bound. So the cursor will pop up somewhere. What you need to do is do your left cursor key and just kind of adjust that. So what I'm going to do is just get that cursor a little bit to the left of where the maximum is. That's good enough. I'm on the left side of that maximum. Then what I do is I press enter. Okay, most calculators will get a line. Now it's going to ask for a right bound. Like this, so I'm going to go a little bit to the right. As soon as I'm past it, I'm good. Press enter again. Okay, and what you've done is you've established bounds. It's going to say guess, so that just means you press enter again, and then it will pop out. The answer will pop out. So what it did on that then is it's saying the maximum, and if you can see that, that's like 3.16. So that would be the optimum way to chop off that square to make your box. So what we would get as a conclusion on this then basically is this. So based on the graph, what we would do is this. And what I want you to do is just draw a real simple graph. Doesn't have to be perfect. Just put 700 there, put 8 there. And this can be a real rough graph on this like that. I'm fine if you do like that. But the key thing on this is you get this point. That point right there, according to the calculator, and I'm just going to round that to 1 decimal, is like 3.2. And then 649.5 like that, okay, and that's what you get. So that means the value of x that would make that a maximum would be 3.2 inches by 3.2 inches. Okay, does that make any sense what I just did? Okay, now that's a calculus problem. That's called an optimization problem. At this level of a class, you can only use technology to figure that out. A lot of you, though, have had calculus before, and you may still remember how to do derivatives and that kind of thing like that. That's what you learn in a calculus class. Okay, does anybody have a question about calculator? If you got a weak background with calculator, that's a good thing to stay after class for sometimes, and let me catch you up on that, okay? All right, any questions on that? Okay. All right, so this is kind of what we have here is x is 3.2. Maximum volume, what did we say that was? 649.5, and that would actually be cubic inches like that, okay? So that's one type of optimization problem that I like to go through, okay? When you get into your test 2 weeks from tonight, you're going to have a calculator part and a non-calculator part. This is a beautiful calculator part question, hint, hint, okay? Because you have to use your calculator to do this, okay? And I want you to be able to get some good skill with your calculator on these problems, okay? All right, so let's look at this next one. We're going to just do 2 more of these types of problems. What this one says is it says the distance from a point on a function to a fixed point. And what we're going to do on this is we're going to just start off by doing the graph of y equals square root of x, okay, like that, okay? All right, so let's go ahead and let's just kind of sketch out a graph. You don't really need that bottom part of the y-axis. You can just kind of write it. You can actually just write it like this if you want to. Just kind of make your graph look like that. Okay, so what does the graph of square root of x look like? That's something you want to know what it looks like at least. That's the swoosh. Good, okay. So, and we are going to do this on the calculator, but I'm going to just make a quick little table of values. You know, until you get to a point where you know these good, you a lot of times have to just make a table of values. So if x is 0, we'd have square root of 0 is 0. If x is 1, we would have 1. If x is 4, we'd have 2, and so forth. Now, that's all I want to do is just get kind of a rough graph just with about 3 points on it, like that. And let's plot those points like that. So you have a point 0, 0, a point 1, 1. Then you have a 0.42 like this. All right, so that's our graph like that. All right, now what this problem is saying is we're going to do kind of an optimization problem on this again. We're going to also plot the point 1, 0. So let's put a little dot there for 1, 0 like that. So what we're going to do is it says express the distance from the point on the graph to the point 1, 0. So the next thing we're going to do is, see, that's kind of a key point. That's 1, 0. Just kind of arbitrarily pick a dot and put it on the curve. And you will call that one xy, like this. Because what we're going to do is we're going to find a function and do something with that. So what I've done is I've done the square root function. I've got 1, 0, and then I've got xy. And then go ahead and connect this like this. And let's call that d like this. Now let me explain what's going on in this problem basically. As this point changes, what's going to happen to this distance? Okay, it's going to get bigger if you go that way, right? That point changes. That's going to get bigger that way. What if I go in this way? Okay, it's going to get smaller. It's kind of hard to tell, but somewhere in there, that distance is going to be the smallest possible. We don't know where. I mean, just by looking, it might be that distance right there, but we don't really know. But the idea is somewhere in there, we can find the point that minimizes the distance to the point 1, 0. Does that make sense what I'm trying to have you do? Okay, so you're doing what we call a minimization problem on this then. Okay, well, what we need to do is we need to come up with a function that we're going to work with then. Okay, what am I doing? I'm finding the distance. So what do I do? The distance formula, exactly. Okay, so what you're going to do is you're going to do the distance between those 2 points right there. Okay, so let's just go with the distance formula. So we're going to have distance equals, then we're going to do this. We're going to do the distance between x and 1. So we say x minus 1 squared like this. And then we do y minus 0 squared like that. Okay, and that will give me d is equal to, I'll just leave this alone, that's x minus 1 squared, and that's plus y squared like that then. Okay, now remember, when we've been doing every single one of these problems so far, how many variables did I say you have to have? You got to have one. We have too many. Okay, we've got x and we got y, so we got to make one of them go away. Okay, I know what y is. Do you? What did we graph? We graphed that, right? So that's what y is. So you're going to replace that y with square root of x. That will give us our one variable. Okay, that's what it says right here. That's the graph that we're working on. So this thing right here is going to plug in right there. Okay, then you're going to have the formula that we're going to work with. So that's going to be square root of x minus 1 squared plus square root of x squared like that. All right, everybody follow what I just did? Okay, you can't do these problems unless you have one variable. Now, if you go to Calc 3, when you do Calculus 3, you start working with optimization with multivariables. Okay, so here's what you'd end up having. Okay, you're going to end up having this. You would have d equals, now we are going to multiply this one out. So we're going to FOIL that out, or kind of do the shortcut that we've done. So we have this. Okay, when you FOIL that out, you're going to have x squared minus 2x plus 1. And then what happens to that radical x squared? That little radical goes away, right? Okay, so we have that. And then we're going to collect like terms. So you're going to have distance equals x squared. These are like terms, so minus 2x plus x is minus x plus 1 like that. So that is the formula that you would end up working with. And that formula gives you the distance from that point 1, 0 to some point on that graph y equals square root of x. Does everybody understand what I did? Okay. Now at this stage, what we're going to do is we're going to graph this on the calculator, and we're going to do that the same way I did the last problem. So do this on your calculator with me. All right. So what we want to do is put this in, run through this with me. Okay. So I'm going to clear this off, and we're going to go ahead and put this in. So you'll put in y1, you want to put in square root. Okay, and underneath that you would put in x squared, and then minus x, and then plus 1 like that. And we're going to just I'll give you a window to do that. And what we're going to do is this will be it's not going to be what I graphed, it's going to be the graph of the function. So for a window, this is what I want you to do is something like this. let's just start with 0, and let's maybe go out to 5 or something like that. So let's go like 0 to 5, maybe by a scale of 1, okay, like that. Now the y's, well, the y's are going to be small. Again, if you want to figure out how to scale y, do this. Look at your table. So if you go second table, and if you begin to look at this, this is what's happening on this problem. It's basically just saying that this right here would be the distance. This is what you would expect. The further out you go, as x gets bigger, the distance gets bigger. So somewhere probably in there is where that distance is at a minimum. So let's do the y like 0 to 10 or something like that, and that's good enough, okay? So let me go back here and put this in like this. We'll put 0 for y min. We can put 10 and then scale by 1 like that, okay? Then if you've got everything in your calculator with your window, and if you type graph on this, then this is what we're looking for a minimum of. And you can see that it has a low spot, can't you? Our job is to figure out what that is right there. That, whatever that x value is would give you the point, the x value of the point that would minimize this distance, okay? All right, so what you do is the exact same thing I did on the last problem. What you do, once you have this graph in, is you go second, trace. Now this time you go to minimum, okay, because we're finding a minimum. Type minimum, and then you want to get a left bound and a right bound just like I did before, okay? All right, so I'm going to move this over a little bit until I get to the left of it. Okay, just be sure that you're convinced you're to the left of that minimum. That looks good enough. And then get a right bound. Okay, and then you'll press enter. When it says guess, press enter again. And then it should come out with the answer. So it looks like that answer is going to be on this. You're going to end up with that point. Is that, I can't see that. Is that 0.5 on your calculator? I think that's what that is. Yeah, that's about right. And it's got some other decimals, but we would round that off like that. Okay, does everybody follow what I'm doing on my calculator? Okay, all right. So what that would mean is you would have this. Now for a graph, I mean, I don't want this to be, this doesn't have to be all that accurate because the idea with this is, let's just say that's 1, that's 1. The graph is kind of doing something like this. Kind of hits a minimum and goes up like that. So that point that we found looks like the point 0.5 and then 0.86 like that. So what that means is, the meaning of what we just found is if you moved this point over to a half, then that would be the minimum distance right there. That's what that means. Does that make sense? Okay, right? So that's a problem that's called an optimization problem. We can find where something's a minimum or a maximum with technology. Okay, you want to make sure that you know how to do that kind of thing. Setting up the function and then using your calculator. Okay, and you will need to know how to do this for your test next week, okay, on the calculator part of the exam. So you got to set it up and you got to be able to crunch it out. All right, any questions about that? Okay, all right, so let's see. That one, I think we got 0.5 is the answer on that. I'm going to do one more to kind of finish this up. It's a very short section, and then we'll start into the next chapter. Okay, this is a little business application on here. I always go over this if I teach business calculus. We look at more like economics and stuff, okay, applications. So what this is this is called a price-demand equation. We're not going to get into the theory of this or anything. But what this is X is how many things you sell, and this is the price, okay? So if you sold X items, you could compute the price, okay? This is giving you a domain from 0 to 1,000. We'll kind of use that when we're graphing. And what we're going to do is we're going to do a revenue function. So what I want you to write down on this is the way a business finds its revenue is they do two things. They take the number of items sold, and then they multiply that by the price, right? So if you have a business and say you're selling lemonade. Lemonade costs 50 cents a glass. Well, if you sold 100 of those, you'd multiply and you get how much money you're making, right? So that's the idea. So what we say on this is we usually say R equals X. X is the number of items sold. P is the price, like that, okay? So what we're going to do with this one, when we get our revenue function, we're going to take X and we're going to multiply this by negative 1/10 x plus 100 like that. Okay, and we're going to work that out, and that's going to be the function that we're going to deal with. So that's going to end up being basically this. This is going to be, do a distributive property, so that's going to be negative 1/10 x to the second, and then plus 100x like that. Now again, we're going to work with this on the calculator, but if you're doing this, that's got one unknown. Okay, so we don't have to worry about doing anything with the unknowns. It's got one unknown in it like that. Okay, so that would be your revenue function then. So the next thing that we're going to do is we're going to find the revenue if 450 items are sold. So what you would do is you would evaluate that function at 450. So I'm just going to take this function where I see an x. I'm going to replace that with 450 squared plus 100 times 450. Now I'm going to just do this on the calculator, and then we'll kind of do the optimization on here next, basically here. Okay. Okay. Now here's what I'm going to have you go ahead and do is we're going to go ahead and graph this revenue function, and I'm going to we'll calculate that thing out in a minute. I'll show you another way of doing that. So what we're going to put in is we're going to put in your calculator. You want to write it probably like this. Okay, our revenue function. Let me move my calculator out of the way. We want to put this in y1. So we want to do this. That could be written as negative 0.1 x squared plus 100x. Okay, so you want to put that in y1. Okay, like that. So negative 0.1, then x to the second, like that, and then plus 100x, and then we're going to graph that. Okay, now what you got to do is you got to think about your window. What did I say about x? The problem said x is between 0 and 1,000. So you need to go ahead, when you set your window up, you want to go from x equals 0 to x equals 1,000. And then what's a good scale? Probably 100. Just go by 100 or something like that. Okay. Now the other thing you want to do is figure out the y's. So you're going to have big numbers. Sometimes on this you just have to take a guess on it. Okay. So I'm going to do something like, I'm just going to take a guess. I'm going to start with y minimum is 0. Then I'm going to say my revenue is 50,000. It's probably too small. I don't know. I'm going to find out, but I'm just going to take a guess and see what happens. And I'm going to scale that by 10,000, okay? Because the revenue is going to be pretty big if you're going all the way out to 1,000. So I'm going to graph it, and I'm going to see what I get. That was a great guess, okay? Sometimes you kind of make a good guess, sometimes you don't, okay? So that would be kind of roughly what your function would look like. So what this is, what's happening on my graphing calculator here is, and this is real logical. This is x is 0. If x equals 0, what does that mean? You sold nothing. Therefore, you made no money. Okay, but your revenue is getting bigger, and then maybe your price is getting too expensive, so people aren't buying stuff anymore. So since you're overcharging people, they're just saying, "I'm not going to buy from you." And what happens is your revenue goes down again. So there's some sort of an optimum revenue in there. So you basically do this the same way. What you would do now is once you got your graph established, again, you would go second trace, and then just do the maximum on that. And let's see what we get. It's probably 500. I don't know for sure, but I'm going to find out. That just seems like that's what it would be. Okay, so that's my left bound. I go through and do my right bound. Okay, then it'll get that. Then guess, press enter, then you'll always know you're right because it blinks on that. So what you're getting on this on your graph then is you're basically getting a point 500, and then that's 25,000 like that. So what that means is, what does the 500 mean in this problem? That's how many things you sold. What does the 25,000 mean? That's the amount of revenue you made. Okay. So a lot of times, like in some of my business calculus classes, stuff like that, you can look at prices and how they change revenue, and you can find a place to optimize that. Okay, that's kind of the idea, what makes that a calculus problem. Okay, so that's mainly what I wanted to go through on that. So what you would end up having with this is the quantity sold would be, what was that, 500 items. Okay, and then the revenue on that was 25,000 like that. Okay, so that's your answer to your problem. Okay, So that's pretty much what you're doing in that section. And you're not going to do, I think when I put the homework up on this, there was maybe 2 or 3 problems where you do your calculator. Most of it is just going to be setting up an equation, okay? It's a fairly short section that you're doing on that then.